In this section, we're going to cover solving linear system by substitution. Now, in the previous section, you solved by graphing, where two graph function intersects, and that's the solution. Now here, we're going to do substitution where 1. Isolate one variable in one equation. 2nd, plug one equation into another equation. So that's what basically substitution means. Plug one equation into another equation. So I need to specify that you don't plug into the same equation into itself. You don't do that. Substitution, you substitute or you plug equation 1 into equation 2. Or you substitute or you plug equation 2 into equation 1, but not into itself, period. Alright, in this example we have negative 2x plus y equals 4 and 6x plus 2y equals negative 1. Now when it comes to substitution, and if you have to use substitution, I always look for the one that has the variable by itself, meaning invisible 1. So if I'm looking at these two, now in the second equation I have a 6 in front of x and a 2 in front of y. So I'm not going to use that one first. But if I look in the first equation, I see there's a negative 2 in front of x, but there's an invisible in front of y. So I'm going to use the first equation. So negative 2x plus y equals 4. Now, the good thing about this is that it only takes one step to get the variable by itself, in this case y. So if I want to get y by itself, I need to cancel out the negative 2x. The opposite is plus 2x. So the 2x cancel out, and I only have the y on the left side. 4 plus 2x would simply just be 2x plus 4, because that's a number combined with a variable. Alright, so I got the y by itself. Now this came from equation 1, so I'm going to plug one equation into another equation, meaning if I'm going to plug or substitute equation 1, it has to go into equation 2, which in this case, this y, because that's what y equals to. So all I'm doing is plugging into y in the second equation. So when I do that, what it's going to look like is just 6x plus 2. Now instead of y, I put this whole thing. That's what y equal to from equation 1. So essentially, instead of y, I'm going to put 2x plus 4 in parentheses. Let me write it in a different color. So again, all I did was substitute, plug into y, or switch out y with 2x plus 4, because that's what we got y equal to from equation 1. So next, to simplify, we're going to distribute the 2 that's in front of the parenthesis. So it will be 6x, 2 times 2x will be 4x, 2 times plus 4 will be plus 8, equal negative 2. And then combining x, that will be 10x plus 8 equal negative 2. Alright, I'm going to write over here to solve for our x. So 10x plus 8 equal negative 2. If I'm trying to solve for x, I need to get rid of the plus 8, so the opposite is minus 8 on the left, therefore minus 8 on the right. So 10x on the left side equal negative 2 minus 8. If you need to double check, always use a number line. But negative 2 minus 8 is negative 10. And if I want to solve for x, I'm going to divide by 10. And then I'm going to divide by 10 on the right. So therefore, 10x divided by 10 will be simply 1x, or just x, equal negative 10 divided by positive 10 will be negative 1. So that's the value of our x. But we're not finished. We need to solve for y. So there's 3 ways you can solve for y. You can plug in negative 1 into the original equation, first equation, or the original second equation, or you can simply plug it into where we got in equation 1, y by itself, because that's what we're looking for. So either way, you can plug into the original first equation, the original second equation, or to the equation where y is by itself from the first equation. Again, does not matter, it all should give you the same answer. But let's say we do this one, where we got y by itself from the first equation. So I'm going to write right here, y equal 2x plus 4. Since we know the value of x, all we're going to do is plug negative 1 into x. So it's going to be y equal 2 times negative 1 plus 4. 2 times negative 1 would simply be negative 2 plus 4. You bring that y down. And then y is equal to negative 2 plus 4. If you need to use the number line, go ahead and use it to double check. But it's going to be y equal negative 2 plus 4 would simply be a positive 2. So that will be our answer. What you can do is you can box up the value for y, box up the value for x, or just like in graphing, you can write as a coordinate point. So my x is negative 1, comma, my y value, which is 2. So you can write it as a coordinate point, just like how you did in solving system by graphing. And you can box that also. Either way, you can write it as a coordinate point, negative 1, comma 2, or you box up the value for y and you box up for the value for x. Either way, does not matter. In example 2, we have a system consists of 6x plus 2y equals 10 and negative x plus y equals negative 3. Alright, so let's try something a bit different. Let's say in equation 2, I want to get x by itself. So in equation 2, negative x plus y equals negative 3. If I want to get x by itself, I need to cancel out the y, which in this case, the opposite of plus y is minus y on the left, therefore minus y on the right. So on my left side will be negative x equal, so negative 3 minus y, number with a variable cannot be combined, so it will just simply be negative y minus 3. Alright, and since I want a positive x, I'm going to simply divide by the number in front of it, which is negative 1. Divide everything by negative 1. So we're simply going to get positive x equal positive y plus 3. So x equals y plus 3. So what we're going to do is simply plug in the value of y, which is, the value of x, which is y plus 3. We're going to plug it into this x right here. Since x equals y plus 3 came from the second equation, we're going to plug it into the first equation. So again, x equals y plus 3 came from the second one, so therefore we're going to substitute or plug it in into the first equation. So it's going to look like this. So 6 in the front but we're going to, instead of x, we're going to put y plus 3. And then everything else will stay the same. So plus 2y equal 10. So we have 6 times y plus 3 plus 2y equals 10. Next, I'm going to distribute the 6 since it's in front of the parenthesis. So it will be 6y plus 18 plus 2y equals 10. Next, I'm going to combine the y's together because they're on the same side. So 6y plus 2y will be 8y plus 18 equal to 10. Now if I'm solving for y, I need to get 8y by itself. I need to cancel out the plus 18. The opposite will be minus 18 on the left, therefore minus 18 on the right. So 8y equal, again, if I want to double check, I use the number line. 10 minus 18 will be negative 8. So I'm going to write right here, no more space, so 8y equal to negative 8. If I want to solve for y, I'm just going to divide by the number in front of it, which is 8. So 8y divided by 8 will be simply y equal negative 8 divided by 8 will be negative 1. Alright, so y equals negative 1. Now, if I want to solve for x, I can use the original first equation or the original second equation, or I can use x equals y plus 3 because it has x by itself, which we were looking for from the second equation. So let's say I use this one right here. So again, you can perfectly use it in the original first or in the original second, and you'll still come out with the same answer. In this case, I would rather use where, since we're looking for x and this equation is equal to x, we're going to use that. So x equal, I'm going to plug in the value for y, so it'll be negative 1 plus 3. X equal negative 1 plus 3, again, you can always use the number line to double check your work, will be a positive 2. Now if I were to write as a coordinate point, it'd be 2 comma negative 1. And I would box that up as my final answer. You can write it again as a coordinate point, or box up the value for y, which is negative 1, and box up the value of x, which is positive 2. Or you can rewrite it as a coordinate point, 2 comma negative 1.